Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into our 10th grade topic, trig ratio reciprocals. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 10th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started! In an earlier video, we talked about 3 basic trig ratios, but did you know if you flipped each of those trig ratios, you would get something pretty special? In fact, if you were to find the reciprocal of each of those 3 trig functions, you would indeed get a new trig function for each one. But before we jump into finding those reciprocals, let's first have a quick recap of the basic trig ratios. Now, this is going to be a very quick and fast recap. If you need a more in-depth refresher on this topic, you can reference my earlier video that I mentioned right up here. But when we're talking about basic trig ratios, the first thing you need to know or remember is we're focusing on the right triangle. So we have this right triangle and we have our setup like this. We know it's a right triangle because we have this box here. We have an angle of interest that we'll put here and we'll denote with a theta. Now, according to this theta, we know we have 3 sides. We have an opposite side to this theta, we have an adjacent side, and we have an hypotenuse. Now, the opposite is denoted with O, adjacent with A, and hypotenuse with H. Now, it's important to note that O and A can change depending on where your angle is. This is where our angle is here, but if our angle was up here, O and A would be different. Hypotenuse is always going to be opposite of your right angle, so that's going to be pretty standard. After our triangle, we know we had our 3 trig functions, our sine function, our cosine function, and our tangent function. And we're finding sine, cosine, and tangent of that interest angle. Hence why we have sine of theta, cosine of theta, and tangent of theta. And if we were to combine these 2 concepts, the triangle and our trig functions, we developed ratios. Now, we had a nice way of remembering which function gets which ratio, and that was SOHCAHTOA. S-O-H, so, C-A-H, ka, T-O-A, TOA. And we can use this to determine which of these trig functions gets which ratio by looking at the first letter in each portion. This tells us which trig function we're focused on. So S would be sine, C would be cosine, and T would be tangent. The next 2 letters are telling you which 2 sides make up the ratio in which order. So means we have the sine function, and we're seeing the opposite over hypotenuse. So it's going to be O over H, or opposite over hypotenuse. The C means that we're looking at adjacent over hypotenuse. So A over H, or adjacent over hypotenuse. And this TOA means we're looking at tangent, and we're looking at opposite over adjacent. So O over A, or opposite over adjacent. But we also talked about how tangent is in fact sine over cosine. So sine of theta over cosine theta. And this makes sense. If you were to substitute what sine and cosine equal, you would end up with opposite over adjacent. So SOHCAHTOA was going to be our nice, easy way of determining which functions get which ratio. But now that we've recapped our basic trig ratios, let's move on to naming and finding our reciprocals. So in regards to our reciprocals, we have 3 of them. We have what we would call secant, we have our cosecant, and we have our cotangent. And these are indeed reciprocals, so technically each of these should correspond to one of these. So we have 1 over sine, that's the reciprocal of sine. We have 1 over cosine, and we have 1 over tangent. Now, one of these may be very obvious. This cotangent is going to be 1 over tangent, and we denote it like this, COT, and put the same theta there. Now, you may have an idea about how to pair up the last 2, but you may actually find this a little surprising. 1 over sine is actually going to be cosecant, and we denote it like this. This is one way of denoting it. You could also denote it like cosecant. Some places will write this, some places will write this, but they both mean the same thing, cosecant, which means that this is going to be secant. So the reciprocal of sine theta is going to be cosecant theta. The reciprocal of cosine theta is going to be secant theta, and the reciprocal of tangent theta is going to be cotangent theta. Now, if these are indeed reciprocals, how does that look for our triangle? Let's make sure we don't forget that we're supposed to be focusing on our right triangle. So if our sine function was opposite of our hypotenuse and cosecant is the reciprocal, that means that our cosecant in terms of this right triangle should be hypotenuse over opposite. Likewise, for our secant theta, which is the reciprocal of cosine, we should get the reciprocal of adjacent over hypotenuse, which is going to be hypotenuse over adjacent. And last but not least, the reciprocal of this tangent, which was opposite over adjacent, should be adjacent over opposite. And just like tangent was sine over cosine, your cotangent theta will be cosecant theta over secant theta. And you can even go a step further because it's the reciprocal of tangent, which was sine over cosine, to be cosine theta over sine theta. And if you was to plug all the stuff in to verify it, you will see that it indeed matches up. So these are going to be the reciprocals of the basic trig functions that we talked about. And you can see their long names, their short names, of course cosecant has another one, and their ratios. But if this is your first time seeing this, remembering how to put all these together may be a little daunting. How do you know which ratio goes with which trig function and not get confused? Well, I have two ways to help you in this endeavor. So unlike the basic trig ratios, there's no nice, easy SOHCAHTOA that can help us here. But I did find two ways that whatever one works best for you could solve that problem for you. The first one I dub think opposite. Now the main thing you need to remember would be the cosecant and the secant, because cotangent is going to be fairly obvious. Cotangent goes with tangent. But how do you not get confused with secant and cosecant? And that's why I dubbed this think opposite. Remember, we went from sine theta and cosine theta to cosecant and secant. But you may be inclined to try to do cosine to cosecant because of the cos, and the sine to secant because of the s there. You may be inclined to do that, but I want you to think opposite. If you start with an s, you end with a c. If you start with a c, you end with an s. If you think opposite, that might help you remember to go from sine to cosecant. Opposite. You start with an s, you end somewhere else. You start with a c, you end somewhere else. Don't try to stay the same, c to c and s to s. That's not the way to do it. Think opposite. The second way that you may have an easy way of remembering is what I dub number 3 is for me. Now, this way is going to require you to not use this form of cosecant, but instead, we're going to use the other form, which was writing it out like this. So cosecant, if you use this form, you can use number 3 is for me to help you remember. The other one is not going to make sense, and you'll see why in just a second. So we have cosecant, we have secant, and we have cotangent. Now, we already said that cotangent is going to be pretty easy, but I want to show you how number 3 is for me works for cotangent as well. Now, you may be wondering, why is this called number 3 is for me? Well, if you look at the third letter going from left to right, that's going to determine which function this is the reciprocal of. So 1, 2, 3, we underline that s, lets us know that this is going to be reciprocal of sine. 1, 2, 3, the c is the reciprocal of cosine, and 1, 2, 3, this t is the reciprocal of tangent. Number 3 is for me is a nice way of remembering, but it does require you to use this other form of cosecant. So if this is not in your book, this may be a little bit harder for you to remember because there's two things you got to remember now. But if this is something you're used to using, this may be a way for you to remember how to pair up your basic trigs and your reciprocals. Well, I hope you're able to follow in today's video and help you now know how you can find your basic trig ratio reciprocals. However, if you have any questions about what you saw today, or even your own homework, you can put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.